here at American Express, and we are hiring. So check out our career website and see if there's any jobs that are a good fit for you. We would love to talk to you, or reach out to me personally if you're interested. All right, let's get started. So today I'm going to be assuming that you have some basic familiarity with Compose, and then we're going to talk about how you would test your composables. So the first thing that we need to talk about is the types of Android tests that we're going to be using today. So I've done a previous video overall view of Android X test and the different types of tests there are. Primarily today, we're going to be talking about Android instrumentation tests. These are tests where you have your APK under test and a test APK, and both get installed on either an emulator or onto a real device, and then it's executed with your tests in the same process on the device as your application, and your test instruments and drives your application. And that's what we're going to be working with today. So a couple other types of tests that you can actually use with Compose. You can do roboelectric tests with Compose, although there are a number of caveats and things that don't work yet in roboelectric tests. So your mileage may vary depending on what you're trying to test. There's a pretty interesting example in the Compose sample app called Jet News, where they have one set of shared tests, and you are able to run them both as roboelectric tests and as Android instrumentation tests on a real device. The advantage of Android instrumentation tests is you can actually see the UI. It's a much more higher fidelity. It is actually Android, whereas roboelectric is on a JVM, sort of simulating a lot of Android things. The Android instrumentation tests take a while to compile because you're compiling 2 APKs, you're installing 2 APKs on the device, but they actually execute faster than roboelectric tests, where roboelectric tests are much quicker to compile because they're just compiling to Java class files and running in a local JVM, and you don't have to build an APK, you don't have to install an APK, but the roboelectric tests can actually take longer. So one has faster build time, one has faster execution time, and roboelectric right now with the Jetpack Compose tests is limited on, there's just some APIs and some things in your composables that don't work yet on roboelectric, but I expect them to continue to improve that in future Compose versions. The other option that's not quite ready but is on the horizon is running multi-platform tests in a multi-platform Compose project, where you're running Compose on desktop and Compose on Android, and you have shared composables and shared tests. So if you wanted to try this out, you would go into IntelliJ instead of Android Studio. You would go into Kotlin. You would do a Compose multi-platform application, and this is going to set up a structure for you where you have an Android source set, desktop JVM source set, and then some common source where you can put composables in the common source and then use them on desktop and use those same composables on Android, and presumably write tests against those common composables. It's currently in alpha state. There's a lot of rough edges on this setup. Getting the dependencies set up right to be able to run tests in this way is not trivial. So keep an eye on it, but it's not quite ready yet, in my opinion. All right. So assuming you have a Compose project and you've written some composables and you want to add tests to that project, you're going to need to add some Gradle dependencies. First one you need to add is UI test JUnit 4. This contains JUnit rules that allow you to interact with your composables. And you add this in as an Android test dependency because it gets put in your test APK, those rules do. The second thing is if you want to test standalone composables and test at the granular level of composables, you're going to want to add an Android test manifest dependency. But this one goes in your debug implementation. And this means it's going to go in your app under test. So it actually goes in that debug APK that you're testing against. And so if we look at what's inside that composable, or sorry, that dependency, we'll look here and we'll see that it just adds an activity. So Compose can start this activity in your process without you having to wrap every composable in activity just to test it. which is very convenient. If we look in the inside of this dependency, you can see there's actually no classes that come along with this dependency. It's just something that gets merged into your debug manifest to allow Compose to launch a generic component activity and then insert your composables into there. And this is all kind of under the hoods, but without adding this to your debug implementation configuration, you won't be able to execute standalone composable tests. All right, so now you've got your Gradle configuration set up and your dependencies added. We're ready to look at some Compose test code. Let's take a look here at what we have. Just gonna delete this. And we'll come back to this later. And we are these so we can. So here's a basic Compose test that we're going to run. And we'll take a look at this afterwards. So the most important thing with any JUnit test rule is to add this @rule annotation. If you just add this and you forget to add this, it's going to compile, but you're going to miss out on, well, it's not going to work, and you're going to get some fairly cryptic runtime errors. So if you get cryptic runtime errors, always double check that you put @rule on all of your test rules. So this creates a test and will give you the ability to wrap your composable in an activity that you don't necessarily have to create. And with the compose test rule and just creating it without passing in the name of an activity, you could just set this on the compose test rule and it will execute your test against this composable and insert this into an activity for you so that it can be tested against. So what we're doing here, this is a fairly simple composable. We have a button with text click me, and then we have a click count that gets incremented in the on-click counter of that button. And I have the same code set up in an activity so that we can just execute it and see what it does. So let's go ahead and execute this. And then we'll run the tests and explain how those work. So you can see it's fairly simple. You click the button, it increments a count. So we have the same code in this test, and then we execute on node with test. We get the node that has click me in it, and then we perform a click, and then we assert that the count is updated to 1 and it is displayed. So we'll run this test, and you'll see the test pop up, and you'll see the UI flash in the emulator real quick, and then we'll see the test succeeds. Cool. So one thing you might notice here is in all of these methods that you're going to be using are extension methods or direct methods on the compose test rule. So you're going to be repeating compose test rule a lot in your tests. So one way to simplify that and remove some of that repetition is to use the with method. So you need to make sure your test method returns unit, because test methods have to return unit, but then you can say with compose test rule, and this will make the implicit this in your whole test code. So here I can just remove that, and now I can remove this, and you don't have to repeatedly say compose test rule everywhere because it's getting that from this that's passed in there. So that can simplify your tests and make them look a little bit cleaner, and they'll look more similar to what you're used to with an espresso test. So we've seen that the test uses this on node syntax. So what is it talking about? If you've written an espresso test before, you will have noticed that it's on view. Well, in Compose, there is no view hierarchy. There are no views. So what are we testing against? Well, Compose has a secondary hierarchy that it gets built out of your Compose call stack called the semantic tree. And that semantic tree, the nodes in that tree are called semantic nodes. And that's what we're interacting with here. And we're going to talk more about that in a second. and how that works. But you'll find that understanding the semantic tree and semantic nodes is really a key to understanding how you can grab a hold of these pieces of your UI and then perform actions on them and perform assertions on them. Before we take a look at that, let's just look at how you might test compose a composable that's in an activity. If you want to test a full screen activity composable that you have already ready to go in your app, you can, instead of saying create compose rule, you can say create Android compose rule. And here I've got that activity that we ran before that has the same code in it. So I can actually just load up an activity and I can run the same test, and this is going to run the same test with this activity. So it's the getting the composable from the activity and then executing this test code against that. But you don't always want to wrap everything in an activity, which is why the other form is nice if you want to test your composables at a more granular level. And you can see this test passed here. All right, so let's go back to what we had before, just testing a single composable at a more granular level where you just say which composable you're going to test right inside your test. So I talked about that this is getting you a handle on a node within the semantic tree, but we don't really see the semantic tree necessarily here. We see composables, we see call stack, and in your UI, you don't necessarily see the semantic tree. So how are you supposed to know what is in that semantic tree so that you can write the proper finder methods that go and find the pieces of the UI so then you can interact with them? There's a couple of ways you can do that. So one of the things is if you're running your UI, you bring it up in an emulator, run the UI, and then you can open up the layout inspector. And I'm using the Bumblebee release of Android Studio here, which gives you insights into the semantics inside the layout inspector. So you can see we've got the code running in an emulator. We've got it up here in layout inspector. It's the same UI. And then we can look at the call stack of our composable here and see how this corresponds to the code that we have in question. So we see a button here, and we can see that that button gets highlighted here. Then we see this text down here, and that's the click me text. And then we also have another text down here, which is the click count text. You'll notice that there's a lot of other things in this call stack here, and these we don't see in the code. And this is the composable call stack. So inside a button, button calls surface, surface calls another surface, that surface calls a box. These are all really implementation details of how Compose is working. And you don't want to have to deal with all that detail in your test because these may change from version of Compose to version of Compose. And so, but your test operates against the semantic tree. So by looking and turning on this option here, highlight semantic layers, it will gray out all the things that aren't actually in the semantic tree. And this is your call stack. But now the highlighted things are corresponding to the nodes that are in your semantic tree. And so these are the things you have access to with the on node and on all nodes and on root in the semantic tree. Now, an important thing to know about semantic nodes is that you have a merged tree and an unmerged tree. You get to think of the unmerged tree as really just the raw tree of everything that has anything semantics against it. So these are grayed out because there's just no semantics attached to any of these composables. And so there's no semantic nodes in the trees for those. But if we look at text and we highlight this and we look over here on the right side, we can see that this text node has declared semantics. The declared semantics are what you are going to see in the unmerged tree. So it would be maybe nice if they put unmerged in parentheses here for declared semantics, because this is what is going to show up in the unmerged tree. So the node, you're going to have one node for this text composable in the semantic tree, and that node has a list of key value pairs. Here's a key, here's a value, here's a key, here's a value. So we can see that there's a value called text here that has, as the first thing in this list of strings, it's actually an annotated string, is click me, and that corresponds to that text. But again, this is the unmerged tree, And we know that because it says declared. If we look at button, button is both in the unmerged tree and in the merged tree. So button has its own semantics, and this is what will show up in the unmerged tree for that button node. But in the merged tree, text won't even show up, because if you remember, if we see here, there is nothing that says merge semantics, which means this node will not be in the merged tree. What happens in the merge tree is mergeable elements, which are generally things that are clickable or focusable, although you can customize that, but generally anything clickable or focusable will be in the merge tree. And what it does is it gathers up all of the semantics from everything down the call stack and attaches it to that node. So if we see here, this has direct semantics attached to it. It has a role, a button, it has an on-click action. In those, we see those both are still existing in the merge tree on this node. But we'll notice that this button, even though it doesn't have any direct text called click me, in the merged tree, it is gathering up everything down the line that had merged things. And so this text is not directly clickable. So it didn't end up in the merge tree, but it got merged up into this button and attached onto that button. So now in the merged tree, this button node has the semantics attached to it, the key value pairs in the merged tree. And by default, Compose will use the merged tree for all of your on-node finders, on-node, all nodes, etc. You can tell Compose testing to use the unmerged tree. There is a flag where you can say use unmerged tree and say true. And that means in this case, it's actually going to find, in the first case where we don't say that, it's going to find the button is the node it's going to find. In this case where we say unused unmerged tree, now that text lives on this node and it's going to find this node. It'll actually work in either case because it's actually sending touch events to the center of the selected item. So it's sending the touch events to the same place either way, depending on which node it finds, but it is actually finding different nodes in the tree, depending on whether you use unmerged or merged tree. So that is one way of finding the merge tree and really understanding it, is when you have an application open, you open the layout inspector, and then you look at you set the highlight semantic layers, then you find the various things that are highlighted. Those are your nodes in your semantic tree, and you can click on them and it'll highlight in the UI what that corresponds to. You can also right click and say go to declaration, and that will put the cursor on the piece on the composable in your source code. So you can map this back to source code, you can map this over to the UI, and then you can look over here to see if it has declared semantics, which means unmerged, or if it has merged semantics, which means merged. And so that really gives you an understanding, allows you to inspect your UI so that you can write the proper statements to grab a hold of the right nodes in that tree and then click on them and insert various things about them. So that's layout inspector. Another way to do this is you can print out the various trees in your test code. So you grab on to the root node, and then you're going to say print to log, and this prints the semantic tree for that node into the logcat during your test. We could print it at different points in the test and see the tree at different points depending on what's happened. So in this case, we're going to see down here, we're going to see the count is different because here we start the count at 0. We're going to print, we click on the button, we increment the count, and we're printed again. We'll see that the count has been changed. So if we execute this test with these new test statements, and then we open up logcat, see when the test runs, it prints out a text version of the tree. So this is the merged tree again, and this is the same information that we were seeing in the layout inspector, but now you can print it out at various points inside of your test. We're seeing in the merged version, the button, the one that had the node that has button, also has the text because it got merged up. In the unmerged tree, the role that has a button doesn't have any text associated to it. It's just got these two things. And then there's another node that is under it in the tree that has the text. And both have this click count text as a separate node. And it doesn't get merged in the merged tree because there's nothing clickable about it. So it doesn't actually get merged up into a button or anything like that. And then afterwards, we can see that the click count is 1 when we print all this for a second time. So this can really help you understand, why am I not matching? Why is why can't my node find anything? And really help you debug and get a hold of the right things. So that's the semantics tree. Next, we're going to talk about some gotchas with how you match things on the tree. And sometimes it'll be a little bit surprising, but once you kind of understand the tree that you're matching against, what is the semantics node, what is the semantics matcher, you can diagnose and fix these problems when you encounter them. So just as an example, we're going to change our setup just slightly here. And we're going to make this into 2 separate composables, one with click and one with me. The UI is going to be the same. It's going to look the same. It's going to be a button that says click me. But now if I rerun this test, you're going to notice that just with that change where the UI is still the same, now we get an error where it says it can't find click me. It's trying to click on that and it can't find a node that satisfies that matcher, which can be a bit confusing where it looks the same, but now my node doesn't match. Well, if we go and we look at the logcat again, it'll give us a clue to why this isn't working. In the unmerged version, we can see that there's actually 2 nodes here. There's one that says click and one that says me. But actually, by default, remember, we're operating on the merged version of the tree. So this is the one that we need to look at. And we can see text is click me, but it's not finding it. Well, what's happening here, and you notice this comma, this is a list of strings. And this matcher matches click me against each thing in the list of strings. So it's comparing, is this click me? Nope. Is this click me? Nope. And then it says, I can't find anything. So you can solve this in a couple different ways. You can adjust your semantics on your tree itself, or you can write a separate matcher that will match this. And we know what the semantic tree looks like. So we should be able to write a custom matcher that does that. So when you write a matcher, generally you're going to want to write a extension function on semantics node interaction provider. This is an interface implemented by Compose test rule. So you can actually run that on Compose test rule. And before we had on node with text, but maybe we want on node with joined text, because we're going to join the strings together that are in that array, because that's the logic we want. And of course, this could be anything specific to your app where you have a specific structure that you want to work with. You need to return a semantic node interaction. This is the thing that it returns that allows you to call things like perform, click, and assert. So that's the thing that gets returned. So we return on node, which is just the general finder method. And then we pass in a custom semantics matcher. So this is just going to go through and look for the node that we want to find. We're just going to slightly adjust the logic. So you give it a string that tells you what you're actually matching on, and then this will have a matcher that takes in a node as a parameter in the Lambda. And then we will look at that node. Config is the thing on the semantics node that has the key value pair. So we're going to get, we're going to pass in the key that we want to look for. We want to look for the text, which is semantics properties.text. And you can see that this is a key. It's a semantics property key. And the type of the value that that key maps to is a list of annotated strings, which is kind of what we're seeing down here. This is a list of annotated strings. So what we need to do there is if we find it, we want to do join to string. We don't want to have any separator between things. And each one is an annotated string. So we need to do text. So this is an annotated string, it here, and we need to get the text, which is the string, out of the annotated string and join it all into one string. And then we want to compare it against the text that we passed in. And so now we have a semantics matcher, has a little bit of a different logic here that includes join to string. before it compares with the text. So now instead of that, we can use that up here, comment out this one, perform a click on node with join text, click me, and we can rerun our test. And see that the test passed. This test would actually pass even in the previous case where it was all one composable, but it also passes in this test case as well. So this shows you, we've seen how to understand the semantics tree, what are semantics nodes, how does that get laid out, how does it relate to your composable call stack, and then to write custom semantics matchers if something in the tree is not quite matching what you would expect. And so I really see that semantics tree, which is also used for accessibility. So you want to understand that for accessibility purposes, but also is very relevant to being able to craft your tests in a way that isn't surprising when you get errors about why can't it find this thing, which to me was one of the most surprising parts about trying to write this test or these types of tests. And then once you have a hold on the nodes that you need to have a hold on, you can do things like get the root node, print it to a log. You can do things like perform clicks on them. There's prefer scrolling. There's all sorts of things that you can do. And then you can do all sorts of assertions on the things that you've found in your tree and make sure that the right things are showing up in your UI after you've operated on your UI and passed in a composable. All right. So let's talk about testing animations in Compose. So I have an activity here that has a composable just to demonstrate the point of what we're going to be testing against here. It's a fairly simple bit of compose code. We have an animation. Every time you click the button, add 5. It's going to add 5 to the count, but we display the animated count, which means we're using a tween. It happens over 5 seconds, so it's a slow animation, basically counting once per second. So it counts up to 5, 1 second at a time. I click the button, you see 1, 2, 3, 4, 5, and so it counts to 5. So that's the thing that we're going to be dealing with here in our test. And delete that for now. So we have a similar test here. Here's the code with the add 5, and it displays the total. But we have an animation now. So how do we control what part of the animation we're testing and control that? Well, Compose gives you a thing called the main clock. It's something that's part of the Compose test rule. We get the main clock property off the Compose test rule. And by default, every time you call one of these methods, on node, perform click, assert, all these Compose test rule methods, it is automatically advancing the main clock for you. So it will advance the main clock as needed when you perform all this, so that the UI is in a consistent state and everything is run that needs to run. Well, in this case, we don't want it to just automatically advance to the end after we do the perform click. So we turn off auto advance. So it's not going to advance the clock when we do a perform click until we manually advance the clock. So we turn off auto advance, perform the click, which would start the animation, but the clock's not running, so the animation's not going yet. We advance the time by 4 seconds plus 1 frame. It needs frames are 16 milliseconds. It needs 1 frame to draw that 4. So it'll display total 4 here after 4 milliseconds. And again, auto advance is still off, so it's basically paused again at that 4-second mark. And it doesn't actually wait 4 seconds. It just instantly jumps 4 seconds ahead in time, which means your tests are going to be a lot faster. It's not like your test is sitting here waiting for 4 seconds. It's actually just advancing the clock 4 seconds immediately. And then we can assert that the total is 4 and assert that that is displayed. So I'm going to execute this test, and what you'll notice, it's not going to count up 1, 2, 3, 4, 5. It's just going to jump right from 0 to 4 because that's where we jump the time immediately to 4 seconds. So the test executes pretty quick, but if you notice, it's going to go 0, jump right to 4, and then the test will succeed. And we have precise control over that animation in a very reliable and predictable way, which was hard to do before Compose, especially if you had animations involved in your tests. The other thing we can do here is we can grab the root of this composable. So this kind of grabs this whole bit of Compose here at the root, capture that to an image, then we convert it to an Android bitmap, and then we can write that out to storage. And the storage will show up on the device. So this is an emulator right now. So if we look at the device file explorer, I'll delete this previous run. So there's no test here. This is in emulated storage, Google test output files. And this is a new method. This write to test storage is a new method coming up in an upcoming version of the test services from Android X Test that allows you to write things out to the file system and works on various API versions. So I'm going to go ahead and execute this test with this new write to test storage. Give it a file name. The test succeeded. Open the device. Here's, all right, test succeeded. We're going to do synchronize, which refreshes what's on the device. We see that this file showed up again and was rewritten, and we can open the file and we can see that at a very specific point in that animation, counting 1 to 5, we took a screenshot. And of course, I could take a screenshot after 1 second, 2 seconds, 3 seconds, see any point in the animation so that you could use these and compare them against like a gold master. Like I know what this animation is supposed to look like halfway through the animation. And you could test your animation visually at different points and control it all very precisely in a very repeatable fashion by using this manual clock advance on your animations. All right. One thing that I wanted to note is that Compose does have its own idling resource. And you may be familiar with idling resources from Espresso, but Compose has a similar but different API mechanism. But you generally will not need that if you're doing Espresso anywhere in your application. Because if you write Espresso idling resources, which you may already have in your application, Compose will synchronize with Espresso. And so those idling resources for things like network calls and other background things that your test needs to wait for, it'll synchronize with Espresso. So if you've done the work to write Espresso idling resources for your app, for your tests, Compose will automatically take advantage of that. But it doesn't happen the other way. So if you only write a Compose version of an idling resource, Espresso won't pick that up. So if you need to use Espresso and Compose in your test, and you can, I mean, they work great together, you will want to use the Espresso version of idling resources, and Compose will automatically pick that up. So it's something to be aware of. I wanted to bring up this testing cheat sheet. We didn't have enough time today to go through all of the different finders and matchers and assertions and actions that there are. We only saw a brief bit, but there's this great testing cheat sheet that you'll find in the docs that has clickable links to an organized fashion of what all of these are, what are all the matchers that are available and the assertions. And you can get collections of nodes and do things on collections of nodes, and you can scroll to things and you can do gestures and things like that. So you can, let's say I want to see this on node with content description. I can click on that and it takes me into the Kotlin docs for that specific matcher there. And I can see more about how that matcher actually works. So definitely look at the testing cheat sheet, go through all these different things that you can do with UI. We just didn't have time for that today to go through more of those. All right, well, thank you. That is the end of my presentation. We're going to go into Q&A time here. As a reminder, we're hiring. Check out our website, check out the testing cheat sheet, and I'm going to take a look at what questions we have now here. So I'm going to look at the Zoom chat, and then after we drop off, please continue to put your questions in the Slack channel, and I'll take a look at those as well. So let's see, we've got. We already have, let's see, I tested using Espresso. Let's see, okay, question. We already have a suite of UI tests using Espresso. We've created a small component in Compose and using it inside of existing screens. Our problem is now that Espresso can't assert Compose views. Do we have anything to help the transition between converting to old views in Compose and keep our Espresso test for the time being? In general, you can just intersperse, on view this in Espresso, and maybe you click on something in a view hierarchy. And if there's a compose on that same screen, you can just use a compose test rule, add it into that same test you already have. And all the stuff we showed today will just work. So you can have an on view this and do this, and then you can have an on node in the compose world, do this, and it will find in your hierarchy the compose. Even if there's a little bit of compose somewhere buried in your view hierarchy, the compose test rule stuff is smart enough to find that compose stuff. So generally it will just work the way you'd expect. You could do on view and then on node and then on view and intermix Espresso and the compose test rule stuff. So yeah, that should just work. And you just add both rules. So you would add normal Espresso setup, and then you would add the compose test rule like we showed today, and just interleave them within the same test. Oh, and apparently you can unmute your mics if you want to ask an audio question, which would be great as well. All right, let me check the Slack channel.
I don't see any questions yet in the Slack channel. But once again, everyone, if something pops in your head later on, feel free to put that question in the Slack channel, and Michael will review it and get back with you.
All right. Well, thank you very much for coming to my talk, and reach out to me on Twitter or LinkedIn, and be sure to check our career website. Thank you very much.
Thank you, Michael.